Hi everyone, I'm Dattaraj. I work for GE Transportation, and today I'll be talking about the industrial internet, how we are enabling the IoT outcomes for the industrial world. I'll talk about specifically GE Transportation. As you may be aware, we are the largest manufacturer of diesel electric locomotives, but we are expanding beyond the locomotive into the rail space and in general transportation. So I'll talk about some of those things, how we are applying IoT to those areas. And then I did want to share one use case of a solution that we developed over the last 3 years on the video analytics and artificial intelligence, which is kind of, and I have some video demos, so I'll try to keep this interesting. And then finally, I do want to spend some time on some lessons learned, especially around this development that we did in artificial intelligence. I wanted to share some insights that we got, both working with universities as well as working with startups, and then what are some of the challenges that we faced. So this, I think, thanks ICT for the very nice introduction. So I won't get more into this, but we can stay connected on LinkedIn, and I can get more details. So as you know, you probably saw in the previous presentation, including Shraddha's, that the internet is touching everyday life. May it be Amazon, Uber, Netflix. There is no aspect of your everyday life the consumer internet is not touching. But at the same time, there is a big revolution happening on the industrial world. So at GE as a company, we make aircraft engines, gas turbines, power generation equipment, locomotives, the business that I'm in. So our customers are expecting these machines to be smarter, connected with better sensors, better connectivity. So if you look at some of the figures of the data that is being collected today, and when an aircraft takes off, say from New York and lands in London, it collects about a terabyte worth of data, just the engine. Now, the locomotive, while completing a trip, has about 9 million data points that is collecting. So there is huge amount of data. I would say compared to the consumer internet, we have much more data that is being generated in the industrial world. And now we need better technology to, first of all, get that data from this remote machine. Now imagine a locomotive, like an Indian Railways locomotive running through remote regions. There may be interesting insights that are happening, which may tell about the health of that engine. But if we cannot get them in a timely fashion, we are not going to get the desired outcomes. So connectivity is a major factor for us. We are partnering with a lot of vendors to help improve connectivity in different regions. Like we have our locomotives running in South Africa, China. So connectivity becomes a very important piece for us. At the same time, we talk a lot about big data and artificial intelligence. So big data, we need ways to store this data. So now cloud is becoming the preferred option to store large volume of data. But we are actually running into cost issues. So we really are partnering with vendors to give us a low cost and a more reliable data storage. At the same time, analytics, and I'll show an example of this. Initially, we had basically rule-based and physics-based models. Now we are getting into machine learning, deep learning, and also when we talk about this data, it is not necessarily structured data. It may be sensor data, but now we are looking at cameras on the locomotive, cameras on the aircraft, getting video data, image data. So we need better algorithms to process this data, and that's where machine learning, deep learning comes in. We cannot just look at an image and say, hey, y is equal to f of x, and say this is a pattern for an object inside of an image. We need some machine learning to keep looking at millions of images and detect that pattern and store that pattern into a model, and then use that model to make predictions when new images come in. So how are we applying this need for data connectivity and IoT solutions to the transportation space? So we are looking at mainly starting with the asset. That's our bread and butter. We make the locomotives. So we have the newer locomotives, the tier 4 locomotive that we released recently. And also just last week at InnoTrans, we released the high-speed locomotive for the global market. These have better sensors, and they can do power planning of the planning for remote monitoring and diagnostics. Planning in the sense that these sensors can now can collect data and do prognostics. So we can tell beforehand if the cooling system has a leak, if the temperatures of the engine are rising, and we can kind of do prognosis on that, just like a doctor would predict some disease and tell in advance, hey, maybe in the next week, bring this locomotive in for servicing. So that's the level of prediction that our customers are looking for. And a lot of these things, this is just a basic example, a lot of these things need to be done real time at the edge. So we need processing capability to process like milliseconds of data or even microseconds of data and show this result. Then we are moving from the locomotive, which is our asset, to the entire train. Now, we often get this, now these locomotives are running all over the track. What we are really trying to do is make these trains self-aware. Not just look at the individual locomotive, but look at the whole train, and can we do better power planning? Like many times these trains have multiple locomotives. Can we plan saying that, okay, use these three locomotives for this trip because this is a very crucial trip. It may not, this particular locomotive may have a failure, and if it fails, the trip may be disrupted. So those kind of decisions we are making at the train level. And then the new area that we are getting into is like a supply chain. So this is not just the train, it could be trucks, it could be ships. So we are looking at the entire network and building software solutions, digital solutions that can help us optimize the network, improve the throughput. So this, I just wanted to share this with a lot of you because people don't really, when we talk to universities, this vision is kind of not really communicated because this is kind of the problem statement that we need. So we talk about big data connectivity, but this is the domain, this is where we need help. So we need better sensors, better data processing, better connectivity so that we can enable these outcomes. So that's kind of the message I wanted to share here. Now let me focus on one particular problem, and I'll walk through some of the steps that we did for solving this problem and building a product that we last year launched called LocoVision Analytics. So the problem was about track inspection. So as the railroads, who are our customers like BNSF, Norfolk Southern, or Indian Railways for that matter, they own the trains, so they buy locomotives from us, and these trains run on remote areas. These railroads have to maintain the track, your railway track, and if there is any anomaly in the track, that can cause derailment, accidents, bad things happening. So the railroads have to follow strict procedures for inspecting the railroad track. Most of the times it is like a scheduled inspection. Like in US, they do it every 2 weeks, and they have to go on those tracks, even though there may be nothing wrong with it. Or sometimes it is within those 2 weeks, they may find that the anomaly is developing within those 2 weeks, and they may not reach it in time. The coverage may not be enough. So for example, this is a track defect that caused a real-world derailment in North America, where because of thermal expansion, the track got bent, and actually the train was derailed. It was a good train, so there was no loss in human life, but there was a lot of damage, in millions of dollars of damage. So what they do is they have these rail cars which are kind of converted to run on a track, and they run these cars on the track, but it's pretty much manual. And what happens is when this rail car is doing inspection, you cannot run a train on it. And these remote areas just have a single track. So you lose availability. Our customers don't get to run train for those 2 hours when the inspection is there, and the goods that are going to be shipped from one place will not reach you. So that's where they lose money. So, so what we did was we started thinking about this, and this is something that we are pretty proud of. This was incubated out of our Bangalore center. So the GE Transportation Bangalore center at Whitefield. So we had a group of engineers who started thinking about this. What are the ways? So we thought about different solutions like sensor on rail car sensors or sensor on the track. Sensors on the track problem was that we really had to go wherever the trains are going and mount the sensors on the track. So the idea that we came up with, can we use the train itself or the locomotive? Can we make it smart enough to start inspecting the track? So that's where the idea of self-aware train came in. So the first thing was, what sort of sensor can we use? So we looked at, the obvious solution was to look at an optical sensor. Can we have a camera that sits on a locomotive and gives me an image like this? And then this is our IoT box. So this box is powered by Ethernet. So we have power over Ethernet cameras connecting to that box, continuously collecting data. It has about 8 terabytes of storage. Now, it was not easy to get such a stable image. This is a GIF, so you may see some flicker, but this is a very stable 1080p image, 1920 by 1080 pixels. And we had to work with a camera vendor to actually stabilize the image. There are advanced sensors in that camera because, as you know, the locomotive goes through many vibrations. So you cannot really, so even if you, the image that you collect is not always stable. We did a lot of testing, worked with the vendor, and finally we were able to get a stable video from the track. So now the Bangalore team started looking at, okay, we have this video, what can we do? How can we extract patterns and help the railroads? And this is something that, this was started about 4 years back. That time machine learning was just pretty new. We were more looking at computer vision. So computer vision is basically, if you ask me, it will be more like extracting geometry patterns from an image. Like an image, like a video is a sequence of images. So an image is basically what a computer sees an image is like a three-dimensional array of pixels, the width, height, and the color intensity, RGB. So from that array of pixels, from that just that pixel, can you extract patterns? So some of the initial work that we did was purely geometry based. So this is an example of detecting Sun King, the kind of the one that you saw in the previous example. So what it is doing is it is marking points on the track, the white color dots, and as soon as the collinearity changes, it starts sending a message, okay, this is Sun King. So this is purely geometry. There's not a lot of machine learning here. What it is doing is, it is taking that image, an array for each image, mapping it to that red rectangle, getting that data and checking the collinearity of the points. So so initial work was a lot around more of a, I would say more deterministic, where we know exactly what we are looking for. We are looking for points on the rail and we can try to flag them. Problems we started running was lighting conditions. So these things, it was very difficult to get these points on the track. This was a clear day. By the way, this image is not a real Sun King. We have doctored, so we worked with a vendor to take a real video and convert it and put a bend, and then we applied our analytics to it. But we did apply this to some real world cases and we were able to solve it. I cannot show them in this in a public forum. So this was some of the initial work on the more of a geometry based model. Then we started showing this to customers, and customers liked it initially, but there was some resistance. They were not sure if we will get the right results. Also, the lighting conditions was a problem. Then when we started showing the demos, they started coming up with new use cases. Then we started so the second use case that so the use case that one of our customers gave us is, okay, if you can process images from the camera, can you detect assets on the track? So this came directly from a customer. We didn't really think of it. We didn't know what was the value add here. So this was a demo that we built for one of our American customers, where what we are doing is, now this is purely machine learning, and as you have assets, like in this case it's a milepost, as you get close to a milepost, it will detect the milepost. This is using object detection. And when you detect the object, it will do optical character recognition, OCR, and give you the value of the milepost. So, and then parallelly, it is building a database for you. This GPS right now is dummy, but one of the things I missed is, along with the video, we are also storing GPS data. For every frame that we are getting, or every 1 second that we collect, we have the corresponding GPS location. So we can say, okay, we found this asset or the defect at a particular location, map it to a GPS, and give that insights to the customers as a report. So they can say that this is an issue. How this is useful is, in the US, a lot of the rules are regulated by the locations of the mileposts. So there is there's a regulation coming called positive train control, where they will start imposing rules like speed limit rules based on location of assets. So the rule may say that up till milepost 200, go at 60 miles per hour, after that go at 80 miles per hour. Now they need to know exactly where milepost 600 is. Sometimes if there is a storm and the milepost is blown away and somebody puts it at the wrong location, in that case that rule is violated. So they get penalized a lot by the Federal Railroad Authority for such violations when the track. So this is something that we developed where not just for mileposts, we are also looking at signals, switches, and finding location of the assets. But the key point I just wanted to highlight here is that we didn't think of this use case. We did a basic demo, showed it to customers, and their feedback was something that was driving this solution. And the final demo that I just want to share is, this is something that we see now very common, but 3 years back this was not that common. Facial detection. So this was done by the global research team in New York, where they do find landmarks on the face. They have some rules that say, okay, based on this the mouth is open, the eyes are closed, or they give a fatigue or distraction score. So the idea of these scores is, so based on these, the geometry of the face, they come up with some factors that this determines if the person is falling asleep or he's blinking too much. So that helps them do a report of the driver. So initially we thought of doing this more of a real-time thing, but the feedback from the customers was, including Indian Railways, was, let's not do this real-time, let's do it more like a report. So they may know that in an 8-hour shift, they're tiring the driver too much, and then maybe they can say that this driver is being overstressed, maybe moving for a 7-hour shift or something like that. So this is another thing that, again, a camera-based solution that we implemented using using this camera system called LocoVision. So now these three examples are shared now. The key thing, like I mentioned earlier, is to getting this data to the analysis or to the cloud for analysis, and then pushing these outcomes in front of the customer. So we are in the middle of developing a platform for the railway. We call it Rail OS, where on the edge, Golink will become our platform, which is the IoT box that we have that will do collection of video data and do some edge processing. So some basic algorithms like detecting the gauge, the distance between rails or sunkings can be done on the Golink. But then we push this data to the storage, and then we have a cloud-based platform where the pattern that we are following is as we build these new machine learning models, we're deploying them to the cloud as a catalog. This is kind of, now this is a standard pattern. If you look at SageMaker or even Google, they maintain a catalog of analytics, and as new analytics come in, you upload to the catalog and connect it to the data. So that's the vision we are doing, and then connecting to a presentation layer and action. The idea is, this is a pattern we're seeing a lot, where you have a common platform right from data acquisition to action, and that's what we are going towards. So that's kind of some of the use cases and our architecture. Now let me come to the last slide, where I just wanted to share some lessons. Now this is something that we incubated from Bangalore, and we were just new to machine learning, and just getting started. So one thing we really found that there's so much information, especially around artificial intelligence in the community. If you look at things like Kaggle, or there's a local analytics Vidya is a Indian side, or Coursera. There are video courses people give away, like the person from Samsung was saying, people give away code on GitHub. So I feel this has been really something that has helped us to get familiar with it. Kaggle is something I would very encourage, I mean, especially for the universities and students. As you get familiar with machine learning, Kaggle has competitions. Even GE hosted a competition where we give you the data, a real world data set, and you can take the data set, build models, and show you results. It has an automatic grading system where you upload your data, it will run a model in the cloud and give you the results back, and it will tell you like a leaderboard how well your model did with respect to others. So in fact, more recently we get a lot of resumes where we have people who have put that they are Kaggle grandmasters, and believe me, we really appreciate that, because that's something that shows that you're more hands-on in machine learning and AI. Also, it's more, we are looking at development of AI workbenches. So if you look at something like Jupyter Notebooks, or especially something like H2O. H2O is a startup from based in California, where they let you build a machine learning model without writing a single line of code. So their vision is that you just have your data set as a CSV or a database. You connect your data source to that H2O. H2O will run it, plot your data, find all the correlations. You can do supervised, unsupervised learning on it. It can be like, if you want a linear model or even deep learning, neural network, you can build that model, and it will, you can build a test set, split your data into training tests, run your model, and get the results. So this is something we are also exploring. And then recently, Google released Google Colab. That's Jupyter Notebooks in the cloud. So one of the things with Jupyter Notebooks is you have to install it on your machine and run it. But Colab is something you don't need any infrastructure. All you do is just an internet connection and browser. You connect to it. They give you a GPU backend. So GPUs are very, like one of the other speaker was talking about. GPUs is something that really accelerates our deep learning workload because of the massive parallel processing. So, so it's almost, we have seen like a 10 to 20x improvement on using a GPU than a CPU for some of the, especially for some of the training jobs. So Colab lets you actually have a GPU machine. So you can upload your data, run the model. Of course, you have to write code, and then it will run on GPU environment and build a model for you. Also, I talked about the platform vision. This is something, even if you look at Amazon SageMaker or any of the products, they are trying to promote like a single platform for all your training, model development, and deployment. And then, like we talked about GPUs, this is something that the NVIDIA CEO Jensen talked in one of his keynotes, that he claims that Moore's law is dead. So Moore's law is something that which says that every 2 years, the electronics development becomes so good that you can pack more transistors in a chip, so that you can, so the processing capability increases 2x every 2 years. But with the GPUs, we see a 10x or a 100x in some cases improvement. So definitely the hardware is getting better. So one of the things we we see is we don't see a lot of institutes taking advantage of that. And NVIDIA has programs where they can actually give you this hardware at a much cheaper rate or even sometimes free. So we in industry try to work with them to get this, but I think the institution should definitely take advantage of this. And finally, just one last thing is what we really saw was as we were building this, the customer feedback was most important. We just showed them some initial demos, but then they said, okay, look at this, look at this. And the same customer who for some time earlier, when we were just showing PowerPoint slides, they didn't really care. They were just saying, okay, go back and do something. When we started showing them the product, they came back to us and saying, okay, now this makes sense, now focus on this area. So it is really important to get the, especially for startups or universities, it's really important to get the attention of the customer by focusing on showing them something and seeing their thought process. It's almost like doing inception, figuring out what they are thinking and trying to focus on it. So that's the last thing I'd like to leave you with. And I'll be around if for any questions, and we can definitely connect on LinkedIn for any follow-ups. Thank you.